So now we'll discuss second case. Here in case 2 we are going to consider roots are real and equal. Roots are real and equal. So in this case what happens? So if the roots are real and equal, so we have m1 is equals to m2, this is equals to m3, this is equals to m4, this and so on is equals to mn. We can consider, since they are all equal, I'll consider it as a m. Okay, so in this case CF I have to write CF, which is nothing but a solution of the given differential equation, or we call it as a general solution since it is a homogeneous differential equation. So therefore y is equal to CF, or is equal to general solution. So we can write this as C1 plus C2 x plus C3 x square plus C4 x raised to 3 plus and so on plus Cn x raised to n minus 1 into e to the power mx. So again, as I told you, if the differential equation is having order n, then it must have n arbitrary constants. Okay, so therefore we are going to introduce c1, c2, c3 and so on, cn, n number of arbitrary constant. Let me consider an example for this one. Here if I consider an example, so d square y divided by dx square plus 2 dy by dx plus y is equals to 0. Let me consider this example. This one is a simple example. So here, as we have discussed in the theory, I'm going to introduce capital D. So it will become d square y plus 2 dy plus y is equals to 0. Again, I can take y term common. So I'm getting d square plus 2d plus 1 into y is equals to 0. So here this is again m square plus 2m plus 1 is equals to 0 is an auxiliary equation. Okay, so again what I have to do, I have to find the roots or factors. So m square plus m plus m plus 1 is equals to 0. From these two terms I can take m common, so I'm going to get m plus 1 plus 1 common from this term. I'm going to get again m plus 1. Since m plus 1 is common, if I take m plus 1 common, so what remains here, m plus 1 remains. So we are getting two factors which are same. So if I equate both the factors to 0, I am going to get m plus 1 is equals to 0 and m plus 1 is equals to 0. So what happens here, m is equals to minus 1 and m is equals to minus 1. So if I consider this root of m1 and m2, so this is minus 1. Okay, so both roots are same, so therefore I can consider this as simply m. So I have to write its general solution. So y is equals to CF complementary function, or general solution since it is a homogeneous one. So the theory I have, since it is a second order differential equation, so must I have to introduce two arbitrary constant, that is C1, C2, x into e to the power minus x. So this is what we have solution for the given differential equation. So let me consider one more, that is for the third case. Here in the case 3, so what we are going to do, we have roots are complex. Okay, so roots are complex roots means they may be in the form of alpha plus or minus I beta in this form. Okay, so in this case I have to write a complementary function. So complementary function or general solution of the given homogeneous differential equation in case roots are complex. So how we are going to write? Y is equals to, or CF is equals to, general solution is equals to e to the power alpha x into bracket cos beta x plus c1 cos beta x plus c2 sin beta x. So this is how we are going to write its complementary function. Let me consider an example for this one. Say for example, d square y divided by dx square plus dy by dx plus y is equals to 0 as an example. So again, with the help of the theory, I can rewrite this as capital D square y plus capital dy plus y is equals to 0. I will take y term common again. So it becomes d square plus d plus 1 into y is equals to 0. Like this we are going to get. So here this will form auxiliary equation, and therefore I can write auxiliary equation as m square plus m plus 1 is equals to 0. So I have to find its roots. Okay, so to find its roots we know m is equals to minus b plus or minus square root of b square minus 4ac over 2a formula. Okay, so here if I compare this, okay, a is equals to first coefficient of m square is 1, coefficient of m is 1 and constant term is 1. If I substitute here, m is equals to minus 1 plus or minus square root of b square means 1 square means 1 minus 4 a is 1 c is 1, so okay, divided by 2 into 1. Okay, so all if I simplify, I'm going to get minus 1 plus or minus square root of minus 3 divided by 2. Okay, so that is m is equals to, and now again if I simplify, m is equals to minus 1 over 2 plus or minus root 3 over 2 I, because of minus 3 I can write this as a 3 into minus 1, so root 3, that is minus square root of minus 1 is I. So this is what we are going to get. So here this is alpha and this is beta. Okay, so therefore here complementary function or general solution of the equation, this equation. So how can we rewrite? So here y is equals to CF is equals to, that is general solution, is equals to e to the power alpha. Alpha in place of alpha what we have here, minus 1 by 2 x, okay, into bracket c1 cos beta, in place of beta what we have, root 3 over 2 x plus c2 sine root 3 over 2 x. So this will become general solution of the given differential equation in case of complex roots. So these are the three cases we are going to discuss when given differential equation is homogeneous, and to find its solution we are going to use these three cases. So similarly we are going to discuss if it is homogeneous, non-homogeneous differential equation, we have few more different methods to solve those kind of differential equation. Thank you.